Here the expansion is the representation of a function as a sum of powers in one of its variable, or in other words, expansion is a series in terms of derivatives of a function at any point or about any point. So, this is the fundamental of expansion of function. Expansion of function for one and two variable both. Now, we discuss about how to expand any function of one variable or two variable. For expand to any function of one or two variable, we can use the Taylor theorem or Taylor expansion formula for expand the function. First of all, we suppose f(x) possesses a continuous derivative of nth order in the interval a to a plus h. Then we have the expansion of a f of a plus h in powers of h. For expansion, we need a function of a sum of two terms. One is first and one is second. Here h is the second term and a is the first term. So, in the expansion of any function in powers of the second term and value of function and its derivative at first term. So, this is the expansion of f of a plus h. F of a plus h equal to f of a plus h raised to the power 1 upon 1 factorial into f dash 1 f dash a plus h square divided by 2 factorial into f double dash a plus, in the general term, h raised to the power n into f n dash a upon n factorial. This equation or this expansion represents the Taylor expansion of f of a plus h in the powers of h. In the second case, if we have f(x) possesses the continuous derivative in the interval 0 to x, then the Taylor expansion or simply expansion of f(x) in powers of x. So, first we need f(x) is the function of sum of two terms. So, first we arrange or first we convert x into sum of two parts, sum of two terms. We arrange f(x) f of 0 plus h. Here x is the second term of this function and 0 is the first term. So, we expand this function f(x) in powers of x and values of function and its derivative at x equal to 0. In the third case, if we have f(x) possesses the continuous derivative in the interval 0 to x, then the expansion of f(x) in powers of x minus a. So, first of all, for this expansion of f(x) in powers of x minus a, we need the second term, we arrange x minus a. So, the sum of two terms of x, first one is a and second term is x minus a. So, f(x) equal to f of a plus x minus a. So, the expansion by Taylor theorem of this function is f of a plus x minus a upon 1 factorial into f dash a plus x minus a whole square divided by 2 factorial into f double dash a plus and so on. So, this is the required expansion of f(x) in the powers of x minus a. And general term, x plus x minus a whole raised to the power n divided by n factorial into f n dash a. In the fourth case, if we have f(x) possesses the continuous derivative in the interval 0 to x, then the expansion of f(x) in powers of x minus 1. So, we arrange f(x) in the second term of x minus a. So, f(x) equal to f of 1 plus x minus a, 1 plus x minus a, x minus 1, x minus 1, and the expansion of this function f of 1 plus x minus a is f of 1 plus x minus 1 divided by 1 factorial into f dash 1 plus x minus 1 whole square whole is divided by 2 factorial into f double dash 1 plus and so on. And in the general term, x minus 1 whole is to the power n divided by n factorial f n dash 1. So, this is the required value of the expansion of f x in powers of x minus 1. Now, we will discuss a problem of a function of a expansion of a function for one variable. If we have f x equal to sin x, then we expand this function because this function is the single variable function. So, for this expansion we need the Taylor expansion of f x in powers of x. Here f x equal to we know that f x equal to f of 0 plus x. Here x is the second term and 0 is the first term of this function. So, required expansion of this function is f of 0 plus x upon 1 factorial into f dash 0 plus x square divided by 2 factorial into f double dash 0 plus and so on, and in the general term x raised to the power n divided by n factorial into f n dash 0. So, this will be the formula for finding the expansion of f x. Here f x equal to sin x. So, we need to expand the function sin x. We differentiate or we require the derivatives of this function and value of this function at x equal to 0. So, the first derivative of this function, it means first derivative of sin x is cos x, and value of this function at x equal to 0. So, f 0 equal to 0, and first derivative of this function is cos x. So, value of cos 0, that is 1. So, value of first derivative at x equal to 0 is also 1, and the second derivative of this function is minus sin x, and the value of the second derivative at x equal to 0 is minus sin 0, that is 0. So, value of the function and value of the second derivative both are 0, and third derivative of this function is minus cos x. So, value of the third derivative at x equal to 0, it is minus 1 because of cos 0, that is 1 with negative sign. Now, putting these values of f of 0, f dash 0, f double dash 0, f triple dash 0 and so on in the equation 1, then we have f x equal to 0 plus x upon 1 factorial into 1 plus x square divided by 2 factorial into 0, x cube divided by 3 factorial into minus 1 plus and so on. And after simplifying, the result or expansion of sin x will be x minus x cube divided by 3 factorial plus x 5 by 5 factorial minus and so on. And this is also known as the Maclaurin expansion of this function. Again, we discuss about the expansion of a sin x in powers of x minus pi by 2. In the previous question, we expand this function in powers of x, but in this question we expand this function again in powers of x minus pi by 2. So, what is the difference between these two? Now, we have the Taylor expansion of f x in powers of x minus pi by 2. That will be, first we arrange fx in terms of x minus pi by 2. So, this is the second term. So, according to this, pi by 2 is the first term, because of pi by 2 plus x minus pi by 2, that will be x. So, we arrange x in terms of two terms. First one is pi by 2 and second one is x minus pi by 2. So, we expand by Taylor expansion formula the value of a function at x equal to pi by 2 plus x minus pi by 2 divided by 1 factorial into f dash pi by 2 plus x minus pi by 2 whole square divided by 2 factorial into f double dash pi by 2 plus and so on. So, this will be the required formula for finding the expansion of a sin x in powers of x minus pi by 2. Now, we required the value of a given function, it means value of a sin x at x equal to pi by 2 and its derivative, first, second, third. Now, here f(x) equal to sin x. So, value of this function at x equal to pi by 2, that is sin pi by 2, it means 1. Now, we differentiate this function first time. So, first derivative of sin x, that is cos x, and value of the first derivative at x equal to pi by 2, this is pi by cos pi by 2, it means 0. The second derivative of sin x is minus sin x, and value of this second derivative at x equal to pi by 2. So, minus sin pi by 2, minus sin pi by 2, that means minus 1, because of sin pi by 2 is 1. And third derivative of this function is minus cos x, and value of this third derivative at x equal to pi by 2 is minus cos pi by 2, that is 0, and so on. Now, we put these values, that means value of f of pi by 2, value of a first derivative of pi by 2, value of the second derivative at x equal to pi by 2, and value of the third derivative of pi by 2 in equation 1, or required in the required expansion. Then we have f(x) equal to 1 plus x minus pi by 2 divided by 1 factorial into 0, because of value of the first derivative of sin x is 0, plus x minus pi by 2 whole square by 2 into minus 1 plus and so on. And after simplifying, we will have the value of expansion of a sin x will be 1 minus x minus pi by 2 whole square divided by 2 factorial plus x minus pi by 2 whole raised to the power 4 divided by 4 factorial plus and so on. So, this is the Taylor expansion of sin x in powers of x minus pi by 2. So, what is the difference between the expansion of sin x in powers of x and powers of x minus pi by 2? When we expand this function in powers of x, the expansion will be the odd powers of the term, and when we expand this function in powers of x minus pi by 2, then we will have the powers of even powers of the term. So, this is the difference. Now, again we take one more example for one variable, the expansion of e raised to the power x. Here e raised to the power x is the function of one variable, and expand this function in terms of or in powers of x. So, first we write the formula for expansion of f(x) in powers of x, in powers of x. So, expansion of this function is f of 0 plus x upon 1 factorial into f dash 0 plus x by x square by 2 factorial into f double dash 0 plus and so on. And general term is x raised to the power n upon n factorial into n factorial into f n dash 0 plus and so on. So, this will be the required formula for finding the expansion of e raised to the power x. Now, we put or now we find the value of the function and its derivative, and we put these values in equation 1. So, we will get the required expansion of e raised to the power x in powers of x. Here we have f x equal to e raised to the power x. So, value of this function, value of e raised to the power x at x equal to 0 is 1, and value of the first derivative of e raised to the power x, again e raised to the power x. So, value of the first derivative at x equal to 0 will be 1. Value of the second derivative again 1, and value of the third derivative again 1, because of any derivative of e raised to the power x is again e raised to the power x, and value of e raised to the power x at x equal to 0, that will be 0. So, that will be 1. So, now we put these values, the value of x f of 0, value of f dash 0, value of f double dash 0, and value of triple dash 0 in equation 1. Now, we have the expansion of f x will be 1 plus x upon 1 factorial into 1 plus x square divided by 2 factorial into plus 1 plus x cube divided by 3 factorial into 1 plus and so on, because of value of the function and its derivative are all 1. So, after simplifying, the required expansion of e raised to the power x will be 1 plus 1 plus x upon 1 factorial plus x square divided by 2 factorial plus x cube divided by 3 factorial plus and so on. So, this is the Taylor expansion, and this is also called the Maclaurin expansion because of expansion of this function in powers of x, and any expansion, any Taylor expansion in powers of x, that is called Maclaurin expansion. Now, we will discuss about the expansion of a function of a two variable. For this, we have the function of a two variable, that means in the form of f of a plus h comma b plus k. So, the Taylor expansion of f of a plus h comma b plus k in powers of h and k both, because of the first term, the second part of the first term is h, and the second part of the second term is k. So, expansion of f of a plus h comma b plus k in powers of h and k, and values of the function and its derivative at x equal to a and y equal to b, because this is the function of x and y both. So, required expansion of f of a plus h comma b plus k is f of a plus b plus 1 upon 1 factorial into h into del f over del x plus k into del f over del y at, and values of these two derivatives del f over del x, del f over del y at x equal to a and y equal to b. And the next term is plus 1 upon 2 factorial into h square into del 2 f over del x square plus 2 h k into del 2 f over del x del y plus k square into del 2 f over del y square, and values of these derivatives at x equal to a and y equal to b, this one, plus and so on. So, this is the required formula for expansion of f of a plus h comma b plus k in powers of h and k. Now, we will discuss about the Taylor expansion of a two variable function in powers of x minus a and y minus b. But we have f of x y. These are not a sum of two terms, but for finding the expansion, we arrange x and y as a sum of two terms. So, we arrange x as a sum of two terms, that is a plus x minus a, because of we expand this function in powers of x minus a, and we arrange y as a b plus y minus b, because we expand this function in powers of y minus b. So, this is the first part of a first term, this is the second part of the first term, this is the first part of the second term, this is the second part of the second term. So, we expand this function in powers of the second part of these two terms, and values of a function and its derivative at as a at uh, as a first part of both term. So, the expansion formula for f of x y in powers of x minus a y minus b is f of a b plus 1 upon 1 factorial into x minus a into del f over del x plus y minus b into del f over del y, and values of these two derivatives at x equal to a and y equal to b, plus and so on. The third term 1 upon 2 factorial into x minus a whole square into del 2 f over del x square plus 2 into x minus a into y minus b into del 2 f over del x del y plus y minus b whole square into del 2 f over del y square, and values of these derivatives at x equal to a and y equal to b. Now, we will discuss about the third formula for finding the expansion of a two variable f of x y in powers of x y. In powers of x y. So, f of x y, we arrange x and y both as a sum of two terms, or sum of two terms, or sum of two parts. Here first part of a first term is 0 and second part of a first term is x, first part of the second term is 0 and second part of the second term is y. So, we expand this function by Taylor theorem or Taylor expansion formula. We expand this function in powers of x and y both, and values of a function and its derivative at x equal to 0 as well as y equal to 0. So, required formula of this function will be f of 0 0 plus 1 upon 1 factorial into x into del f over del x plus y into del f over del y at x equal to 0 and y equal to 0. And the second term, next term, plus 1 upon 2 factorial into x square into del 2 f over del x square, and value of this derivative, the second derivative at x equal to 0, y equal to 0, and plus y square into del 2 f over del x square del x square at x equal to 0 and y equal to 0, and the third term of this 2xy into del 2 f over del x del y at x equal to 0 and y equal to 0. Now, we will discuss about the expansion of any function of a two variable. Now, we take a function of a two variable, it is denoted by f of x y, and value of f of x y here e raised to the power x into cos of y, because in this function we have two variable x and y both, and we expand this function near the point of 1 comma pi by 4 or about the point 1 comma pi by 4 or nearer the point 1 comma pi by 4 or in powers of we can change the statement of this expansion formula. We expand this function in powers of x minus 1 and y minus pi by 4. So, first of all, we take f of x y equal to e raised to the power x into cos of y. So, we know that the Taylor expansion formula for f of x y in powers of x minus 1, because of we expand this function about the point x equal to 1 and y equal to pi by 4. X equal to 1, that means power of x minus 1, and here y equal to pi by 4, that means power of y minus pi by 4. So, formula for this f of x y equal to f of 1 comma pi by 4 plus 1 upon factorial 1 factorial into x minus 1 into del f over del x plus y minus pi by 4 into del f over del y at 1 comma pi by 4. 1 comma pi by 4, that means at x equal to 1 and y equal to pi by 4. The next term of this expansion, 1 upon 2 factorial into x minus 1 whole square into del 2 f over del x square plus y minus pi by 4 whole square into del 2 f over del y square plus twice time of x minus 1 into y minus pi by 4 into del 2 f over del x del y, and values of these derivatives at x equal to 1 and y equal to pi by 4. So, this will be the required formula for finding the expansion of any function of a 2 variable in powers of x minus 1 and y minus pi by 4. Now, we need or we require the values of a derivative of f x. Here f x equal to e raised to the power x into cos of y, and values of this function and its derivative with respect to x and y both at x equal to 1 as well as y equal to pi by 4. Because f x equal to e raised to the power x into cos y, so value of this function at x equal to 1, that means e raised to the power 1 into cos of pi by 4. E raised to the power 1 and pi by 4. These are the values of derivatives and value of the function. Now, we putting these values of functions and derivatives in the formula for expansion. We will have the value of f of x y equal to f of 1 comma pi by 4 plus x minus 1 into this x minus 1 into e raised to the power 1 upon 2 factorial plus y minus pi by 4 into e raised to the power 1 divided by 2 factorial under root 2 plus 1 upon 2 factorial into x minus 1 whole square e y under root 2 plus y minus pi by 4 whole square into under root e minus e divided by under root 2 plus twice time of x minus 1 into pi by 4 into minus e by under root 2 plus and so on. So, this will be the required expansion of this function in terms of or in powers of x minus 1 and y minus pi by 4. Thank you.